Welcome back everyone. Today we'll be looking at how to model a simple essential oil bottle. Here I have a citronella essential oil 15 ml. Okay, so observing the bottle from on the top view, we can see it is a simple circular geometry, and using a caliper to measure the exact values, we can see we have a value of roughly 19 ml, 20 ml. Next we will measure the body of the bottle. We get around 24 ml. And lastly, the length of the bottle. Since this is a simple geometry, it's not recommended to use a sketch, profile, extrude approach, so I'll be using the simplest approach, which is just to use the circular geometries and extrude it to get the overall shape. Moving on to the next object, which is a cell phone. As you can see, it's a pretty simple shape, just a normal rectangular object that is extruded with some thickness. So first, the side view. As you can see, it's a modern cell phone, very thin, low profile. Now looking at the top view, you can see it's a rectangle but a very narrow one with a slight bevel around the edge. And looking at the length way is pretty much the same thickness, just with a different bevel. Now using the caliper, we'll measure the width of the fold, which is 70 ml. After we measure the width, we'll measure the length, which we get 147 ml. And lastly, we'll measure the thickness of 9 ml. Alright guys, we're making some progress here. So moving on from the simple shapes to some more organic geometries, we'll be using this Irish potato for a simple exercise to show the principles of compound or complex geometries. Because the potato is irregular shape, here I'm using the maximum length, width and depth to have an estimate idea of how big the potato is. So because the potato is not uniform in any dimension, I'm just going to show you how it's kind of impractical to use the maximum dimensions, because the potato size varies as you go along the different edges. To further explain on this principle, I will do something I would not recommend, which is just slicing up the study objects in different layers to have a better idea of the anatomy of the object. Now that the potato is sliced up in several layers, we can see different outlines of the cross-sectional areas of the different pieces. Therefore, using the first method by extruding a flat surface into a three-dimensional surface will not work. Because the original method of extrusion will not work, I will have to do a more compound and complex process, which I'll explain later on in the video. Now I'm just going to put back the different layers together to show you the overall shape and how they line back. Congratulations for watching the video so far. Now you are fully able to make potato fries. Yeah. Like to keep my videos short, and I think so much information was shared here today. I'll cut this video into 2 parts, so please subscribe and follow us so you can see the second part where we go onto the computer and start to do the actual 3D modeling. So once again guys, thank you for following me, and see you in the next video.